All right, we're going to go live here in just a few minutes. We're going to get everybody warmed up, and here at the show, we're letting our friends over at Big C make their way over to watch today. So welcome everyone. Hit the YouTube chat. I'm watching the chat here on my computer. If you're watching from Zoom, hit the Zoom chat, and we will get this party started here in just a minute. Welcome everybody who's joining us. If you're just joining us, throw a chat in the chat line, say hi to Joe and I, let us know where you're coming from. We're excited to get started. Joe is all prepped. I've had a preview of his presentation, and I'm pumped to see this presentation. I hope all of you are as well. So thanks for joining us. If you came from Big C or if you joined because you're a Converge PoE fan, we're glad you're here, glad you could join us. We're going to start here in just about 1 minute, and I'll just give a quick introduction, and then I'm going to hand it over to Joe to have Joe present. So I think for those of you who've been on the show before, Joe has presented to us last Big C, and we thought, hey, he did such a good job, he's going to have to present again to this Big C. He'll be presenting from his hometown in Portland this time. Last time I think he was here in Austin, but we're going to let him stay home this time and present from home. And we're going to be ready here in about 40 seconds, so thank you for your patience. We're looking forward to having you all here. All right, Peter, thank you. A jacket and a tie. Yes, I'm wearing a jacket and a tie, and I did convince Joe to wear a jacket too. So he's looking handsome, ready to present. We're going to start here in about 15 seconds and get this very exciting presentation on how the top 3 strategies for designing a PoE lighting and automation system started. So let's go ahead and kick this show off. How you doing, everyone? Tyler in Texas. We're streaming to you live from the Big C Virtual Winter 2021 Conference. We're so excited to be here and have all of you joining with us today. We have a very special presentation. Our CTO, Joe Herbst, is going to be presenting on the top 3 strategies for laying out or doing a PoE-based lighting and automation project. It is a fantastic presentation. I've seen it myself, so rather than have you hear me talk about it, let's get right to Joe. I'm just going to do a quick intro video, and I'll be right back to get this party started. Excellent. So, without further ado, let me get the screen set up so that we can have our friend Mr. Joe Herbst do his presentation today. I'm going to turn off this pin. It takes me a second to get everything set up so that I can get this all going. And let's get this kicked off now. So Joe, take it away. You can start presenting your screen. I think that you're what we see now.
All right. Can you see that?
Yes.
Okay. Well, thank you. I appreciate the opportunity to present today. Just a quick background on me. I come from the high-tech world. I got into lighting and lighting controls back in 2008 when I founded a company managing outdoor wireless lighting controls. I became quite enamored and fascinated with lighting all the way down to, studying particle physics around it. So it's, for me, just a passion project as well as a career that I've encapsulated. What I'd like to present today is kind of top 3 strategies for designing the controls of an automated lighting system. So lighting controls is, 100-year-old industry. It's transformed and changed more in the last 2 to 3 years than its entire history combined. So would like to kind of give you kind of the bleeding edge of what is in the lighting and the automation world. POE Texas is kind of leading charge in terms of building automation, lighting kind of being at the core of that. So with that, I'd kind of just like to give you a little bit more about lighting. What is lighting? So top 3 strategies. Know what you're going to control. I mean, lighting is one piece. There are a lot of other things we're going to control in a building. Why are we controlling it? And then ultimately, how are we going to control it? So those are essentially the 3 strategies. I'll go into a little bit more of each. But I wanted to at least kind of give you a quick thumbnail sketch of lighting. So before we go into controls, let's understand a little bit more about the science and mathematics of lighting. I'm not going to make any major, educational course on this. This slide, I know there's a lot here. Don't get overwhelmed by it. I'm really just going to talk to it. And maybe if nothing else, just give you an appreciation for lighting consultants and lighting designers. And there are engineers. Illumination Engineering Society is an example of an entire group of people who study this day in, day out and have made a tremendous amount of contributions to our world. All I kind of want to go through is just a couple of things like, for example, the spectrum of light. I mean, you have a full moon, which is as little as a foot candle, all the way up to direct sunlight, which is 10,000 foot candles. Well, what's a foot candle? Well, it's the amount of light that you see from a candle 1 foot away. That's the imperial version of it. The metric equivalent is lux and lumen. How do you want to think of this? Well, think of lumens as like pounds, and a foot candle is pounds per square inch. So really we're talking about intensity of light and then light pouring out of a light fixture. So luminance is kind of lumens over a given area. One of the things that is pretty significant is that light dissipates or diminishes according to what's known as the inverse square law. So essentially lumens fall off proportional to 1 over the square of the distance. And so I've got a pyramid, but a sphere is another example. So essentially, as the light gets farther and farther and farther away, it falls off in terms of its intensity or perceived intensity at a rate of 1 over the distance squared. If I can give you a 10-second level of appreciation, the sun is 98 million miles away from us. 1 over 98 million squared is a really, really, really big number. So if you want to think about how bright the sun is at its source, that may give you some scope and scale. We have other sources of light within a building. So how much light do we really need when we're, in a room? Well, I mean, there's a lot of factors to that. So there's sources like the monitors sitting in front of me. They're contributing a ton of light into the room. Skylights, windows. How old are the occupants? People who are over the age of 65 take twice as long to respond to light change and have much lower ability to discern details. What's the type of facility? Is it a car detail work shop where you need, 100-foot candles of light, or is it just an ordinary everyday office or a lobby where you only need 20 to 30-foot candles? And then there's budgetaries and features and aesthetics. I mean, what type of light fixture do you have? Do you have this beautiful pendant or this, linear, or do you just have a basic 2x2 troffer? Finally, one of the things that I'd like to kind of highlight in this new world of moving from incandescence to fluorescence and then fluorescence to LEDs, we've come to install LEDs. The number one complaint after an LED installation is that it's too bright. It's kind of ironic, actually, given how efficient they are. And they've gotten so efficient now that you can essentially put all the lighting in a building on one or two circuits of your electrical panel. But this technology has afforded so many new technologies in terms of design aesthetics and capabilities as a result of the efficiencies it's brought. So with that, I will move on, but I wanted to just kind of pose this question to you. So how is it we see so well in as little as 1/10 of a foot candle? And literally you can buy moonlight, read a newspaper, right, at 1/10 of a foot candle, and yet walk out into the sun that's 100,000 times brighter and not get blinded. So the answer lies in one of the most amazing organs that we have, which is the human eye. So it's truly a marvel of evolution. So obviously there's pupil dilation. So, a light will cause your, pupil to dilate or to get smaller. But within your eye, there is an entire world of amazing evolutionary science. But the two that kind of jump out are, one, that in daylight, your eye is actually very sensitive to green, and that comes from essentially our land hunter ancestry. So that's where we're most sensitive, is in the green wavelength spectrum. At night, when it gets much darker and the scotopic lighting is much more prevalent, we're much more sensitive to the blues and the ultraviolets. So this makes a big difference, for example, if you're designing street lights in a city and you're dealing with very, very low lumen settings versus a retail where you have high lumen settings. So for example, looking at the reds or the greens in a dress or a shoe or a Coke bottle have different lighting design constraints and focus than, say, a street light or a parking lot light in a city and setting. Having said all that, the most important element that we will perceive is contrast in lighting. So there's something called uniformity that is probably the most important design criteria within a lighting project. And you can see a couple of examples here. I've got streetlights where you've got legacy high pressure sodium that have been retrofitted with LED. LEDs also brought about this amazing capability of uniformity and distribution of light. So that is why you can, in moonlight, at 1/10 of a foot candle, read a newspaper, is because of the uniformity. You can see a couple of other examples, like in a warehouse where you've got hot spots. Those are very difficult for someone moving through that space to dynamically adapt. And this is all subconscious. You don't recognize that your pupil is dilating or constricting. But these are things that your muscle memory does, all the time. So another example of how lower intensity that's more uniform has a better perception than higher intensity with poorer distribution and uniformity. So let's tie back to the mathematics. Okay, we talked about the kind of qualitative and aesthetic elements. This is what lighting designers do all the time. They'll take a space, and there's a phenomenal amount of mathematical and modeling tools that are available. I took some of the simplest here as just an example. On the right, this is a space that was designed with high intensity, like high pressure sodium lights, warehouse, for example. On the left was LED. The uniformity is most closely modeled by what's called the min-max ratio. So you can see in the high intensity, old legacy pressure sodium, it was a 10-to-1 or 10.8-to-1 ratio between the max and the min. Whereas LED, that brought it down to a little over 2. So what that does is essentially model the uniformity of the distribution of light. And so you really want to have light sources that are distributed as widely as possible so that when they're added with other light fixtures, you get a nice even flow of light, if you will. And I really would like to kind of end on with lighting. There's just something about really good lighting with the controls that just creates an emotional connection to space. And this is what architects do exceptionally well, and lighting designers, is they find ways for a space to light up, not just, you know, physically, but emotionally, and you connect with it in ways that you would not otherwise do. Okay, so having done all that and talked about all that, let's talk a little bit about controls. Controls is a spectrum. Truly, it has its history and simplicity of a wall switch, but whereas lighting is as much, you know, focused on a product and its characteristics and capabilities, controls is much more of a system. So it's integrating not just lighting, but other pieces, but it's taking intention and essentially implied requests and translating that into a corresponding response. So at the bottom end of the scope is just a wall switch, on and off, right? Move that up a notch and we go to just dimming. I now want to adjust the intensity of a light fixture. One step further, now we're getting into scenes. So, you know, we have Zoom conference scenes, we have in-person scenes, we have dinner mood scenes, lunch, breakfast, cleaning. In the 80s, we got into much more energy-centric focus, so we wanted to be able to turn the lights off automatically when people weren't there, so we get into occupancy sensors. These are what I call event-based response. Event in that they have no time association or affiliation. We got a little bit more sophisticated and then started bringing in schedules and time sweeps. So at 8 o'clock at night, turn all the lights off. At 5 o'clock in the morning, turn them all on. And then in the 90s, building management systems started kind of into the foray of, you know, getting to tie all these bits and pieces together. And we're kind of now into this Internet of Things where there's literally billions of sensors and widgets and whatnot that are out there. We strongly believe that Power Ethernet and PoE infrastructure can tie all of these together in ways that aren't available today. Okay. So again, I know this is a little bit busy slide, but I kind of want to just give you an idea of what are the ways to control lighting. And obviously there's control beyond lighting, like HVAC and door access control, etc. For this, I just want to focus on lighting. We started with high voltage, on-off relay and time clock. That's probably the lowest level of sophistication you can have. Moving forward, Lutron kind of made its way into the world by inventing this phase dimming. Phase dimming is literally up here on the right, and essentially it's showing and essentially cutting the waveform that's coming to your light fixture some percentage of the time. Your human eye, going back to the human eye and its amazing capabilities, integrates that. So when you see a light that's dimmed down with a wall switch in your dining room, what it's doing is essentially 50% of the time literally cutting the voltage off to that fixture. Your eye then just essentially integrates that into a perception of a lower light level, but you don't see that flicker. Sometimes if it's broken, you will see that flicker, and that's why you're like, what's going on? We stepped forward into the LED world, and that really called for a new type of dimming. So that was essentially the invention of 0 to 10 and 1 to 10. I'll spare you the details of why there's two, but essentially that gets into a more precise level of control over the dimming level of those fixtures. As we move forward in terms of sophistication, low voltage, to really do precision level dimming and to do precision level control of light and color temperature and color, you have to get into the DC domain. You cannot do it in the AC domain. It's just technically and cost prohibitive, technically exceptionally difficult, and economically just not viable. So the world really moved into low voltage, and you get into the simplest of, you know, pulse width modulation, PWM. That's essentially, if I got a red, green, blue RGBW color strip, I can pulse each one of those in this manner in terms of creating any color, any intensity, but it's, again, a very high precision way of controlling multiple channels of light. DALI is also another low voltage technology that's used prevalently and predominantly in Europe. It's not as used as much here in the United States, but it is a two-way communication means to have individually addressable fixtures and be able to control fixtures on an individual level. It does not carry any power with it. DMX was essentially a standard developed for theaters. So theaters really need extreme precision and very tight level control, you know, as actors come in and off stage. Cues and sets have to have this level of precision. And then what we're kind of all about is Power over Ethernet, which kind of encapsulates all of this under one cable, one technology, one software platform, and essentially carries with it power as well as high speed data. So that is kind of the forefront of where we're at. Again, I'm not going to go into the details here, but what are the types of controls of lighting? Everything from occupancy sensors and daylighting. Daylighting is if you have light fixtures near the window and the sun's shining in, why should you have the lights on at 100%? There's energy code, California Title 24, and ASHRAE that basically say if you're within 1 or 2 window heights of a window, you should be dimming those light fixtures down. We can get into a whole discussion about shades and adding shades into that whole mix. Hopefully you saw our presentation yesterday where we had Andy talking about well and lead and shading and shade controls. Another form is personal controls. So everything from a wall switch to, you know, personal choices. I know a lot of people who have 2-3 monitors and don't want the lights. Like for example, here, I have plenty of lights over my head, but I don't like them on when I'm looking at screens. Tuning, dirty little secret, most of the sites that I commission, I actually put the top 100% level at 70%. So right off the bat, we can save 30% off of most building facilities operating costs just by trimming it to 70%. And that goes back to the number one complaint that we often see is that LEDs are too bright. And finally, plug load. It's kind of like, no one really thought about it, but the AC receptacle underneath your desk, when no one's there, heat, you know, devices or whatnot that are sitting there don't need to be actively running. So there is, again, California Title 24 and ASHRAE energy codes that say if a space is not occupied, you have to turn off the plug load in addition. When we talk about controls, I'd also like to distinguish controllability versus observability. And it's kind of a weird construct, but if I give you a couple of examples, you'll probably see what I mean. So remote access is an example of controllability. I'm physically controlling something that's far away, but I have no observability to it in many instances. So I can sit there and make a change, but if I'm not physically there, I don't actually know if that tree fell in the woods, for those who know that reference. Observability with no controllability is an energy meter. I can essentially see how much power I'm consuming, but ultimately, if I have no control over it, it's just a window into what's happening. Streetlights are an example of something that's not really controllable and not really observable in most instances. So you don't notice the streetlight's out until you actually drive past it. And ultimately, you don't have any control over it. Yes, it's predictable in that it, you know, turns on with sunset and turns off with sunrise, but it's not actually controllable in most cases. And then obviously when you get into building management systems, you get both. Okay, I'll take a quick 2-second breather. Now, let's talk about what are we gonna control? So obviously there's a myriad of things we can control. Let me give you a couple of examples of the things you should not control. I can't tell you how many times I've gone into a bunch of designs and people want to hook up things like the exit lights or the safety lighting to controls. I'm like, stop, no. This is something you should just hardwire to a UPS backup, never have any kind of controls over it. I mean, an exit sign consumes 1 watt of power. There's never going to be a situation where you're going to want the exit sign to be off, right? So why hook it up to controls? You should only hook controls up to things that you want to turn off, turn down, or turn off. So these are examples of things you should not control. These are just examples of things you should maybe dim when no one's around, but you shouldn't turn them off because the liability cost is much, much greater than the energy savings. I didn't add it here, but another good one is warehouses. So warehouses, you know, if no one's in the aisle, turn it off. I would argue turn it down to 10%, but not necessarily turn it off. So in instances like this, the liability of someone tripping and having a, you know, issue or an injury is really not worth the energy savings that you're going to take away from this. This is an example of things. UVC is a big popular thing right now. I know surface sterilization and COVID and all the other things that go in with it. I'm not going to pass any judgment on that, but I am going to say that if you are going to install UVC lighting that does surface level sterilization, I cannot emphasize enough, you have to be really like detail oriented. I would exercise redundancy in those controls and make sure that you have a really sophisticated turn-off mechanism. So those are just examples of, you know, what you're going to control and what you need in order to support it. There's another concept I talk about, which is the fidelity of control. So how precise, how many control points do we want? So if every fixture is individually controllable, which is the highest fidelity you can have, then you are incredibly capable of supporting change. So your element, your flexibility is now as good as it can get. The alternative is you have a control point that controls a multitude of fixtures, 1, 2, 10, 20. That is a much lower fidelity, and then your ability to control that drops closer to a wall switch than it does, say, a wall station. One of the things I'd like to emphasize that, like systems with PoE or low voltage controls, the benefit of flexibility is that you can now build buildings and have the agility to take on change requests and not incur massive costs overruns. So we've had a number of stories. I told one yesterday, but essentially with a PoE system, somebody makes a change request, it costs them virtually nothing in terms of time or even material cost. So the beauty and benefit of PoE-based lighting control systems really comes when, you know, we're working with, you know, 60% information and somebody makes a change request. It doesn't require this massive upturning of the infrastructure that was built, and enables you to essentially program in software the change request and not have to rewire. This is a fun story. Just, I mean, we've all talked about like the design and then actually how it was built. This is just one example of a design I did where I went into great detail in terms of, this was a restaurant, Hudson Bar and Grill in Jersey City, New Jersey. But essentially we went through in great detail. We talked about every zone, what was in the zone, how it was going to be controlled, the software and all that. So this was handed off to the installer. On the right-hand side is what I got back. So this in 2 pictures essentially explains why you need flexibility. You can have the greatest design in the world. You can pay a top engineer, top dollar, top architect, top dollar. And the reality is when it gets down to the install, if you don't have flexibility, all of that money, effort, time, intention that was spent on architects and engineers essentially gets lost. So that is why having that flexibility can be so valuable. All right, so why are we going to control it? So I break this down into 2 elements, a qualitative argument and a quantitative argument. Quantitative is a little easier because, you know, I like the mathematics and the predictable side of things. From a legal obligation perspective, you got city and state code compliance, whether it's California Title 24, ASHRAE. The 3 kings, as I call them, of energy code are California Title 24, which is the most aggressive and kind of leads the pack. Followed closely behind that by 2 years, give or take, is ASHRAE, and then further back is IECC. ASHRAE is kind of the most predominant standard. Having said that, there are a multitude of city variances and or local variances that spin off different pieces of this for different applications. So that is why we essentially built a software-centric platform, again, dealing with flexibility, you know, as code changes, but more importantly, as you take a solution from one place to another, you don't want to be boxed out because of a limitation in your system. Another lead, Tyler can talk to it a little bit later, or Hannah, I know she may have alluded to this. LEED has now drawn some focus on DC power distribution within a building, and that's obviously something we can support. Other side of the quantitative is economics. So a lot of these return on investment is less than 3 years. So that's a lot from the operational savings that you get as a result of switching to LED and controls. But you also get new efficiencies from observing stuff that you never knew before, like whether rooms are being used or occupied or not. Having insight to temperature variance within a building to know whether or not your HVAC is efficient, whether or not your windows are bleeding, heat out of them or bleeding cool out of them. In many instances, like commercial real estate, you want to be able to attract new customers and clients and clientele. So there's an element to attracting new revenues of function of having this. And then I have to talk about the law of diminishing returns. So you want to find that right balance in terms of optimal capture of the investments relative to the dollars. And so all ROIs kind of have a peak at some point. So finding that is a quantitative discussion. On the qualitative side, there's a whole set of things that come into play, and how you weigh this is a very subjective opinion. So none of this is, judgmental. It's actually, I'm a hardcore advocate of a lot of these, but environmental stewardship, that is a very germane topic today. And there's a lot of design focus centered around that. There's a lot of market pressures. I mean, like Walmart, Google have all announced, grid neutral initiatives within their corporations. So there's market pressures to support becoming much more efficient with energy. And I know that ties into environmental stewardship, but it also just ties into vendor preference. So choosing vendors that tailor to your values. A form of differentiation. So companies like to differentiate, people like to differentiate. There's a cool factor element to a lot of this stuff. That uniformity discussion we talked about. So to the degree that you want to add controls to support a more uniform light distribution. And then ambiance. I mean, when you walk into a restaurant, that lighting is precision controlled, right? You've got a lot of thought and time and effort that goes into, for example, restaurant lighting or hospitality lighting, because it has that mood and that effect. All right, so how are we going to control all this? I'm going to give you a couple of examples. I find these just interesting because, it's kind of how do you bring all this stuff together. So I have this one conference room example. I kind of drew all these graphics, but essentially you've got a conference room here, and let's just say it's in California, where I've got an occupancy sensor, I've got a light sensor. So we've got an occupancy sensor, a light sensor, I've got a wall station or a tablet here. I've got this cove lighting that's essentially in this blue strip here. I've got a linear fixture that's CCT color tuning 2700 to 5000 Kelvin over the conference room table, and I've got some entry lights here. So let me show you, for example, how an architect or a lighting designer would see this. Well, they would say, I've got a type A that's 0 to 10, and I've got a type B that's phase dimmable, these downlights. I've got a type C and a type D. So that's how the designer sees it. This is how Energy Code sees it. Energy Code says, hey, I got a daylight zone here that I need to track differently than non-daylight zone. In California, you actually get 2 of these. And I've got an occupancy, which is the entire room. How users see the room. Now I've got a completely different perspective. I want to control these with different wall switches or wall buttons. I want group 1 to be this collection of fixtures right here on the front. I want my cove lighting to be essentially controlled independently. I want my downlights to be controlled as a third group. And I want my overhead light on my table as a fourth. So I've now got 3 different vantages into the exact same physical place, right? In this first example, I'm basically going to take you through 4 different technologies of lighting, just to be difficult, but that's what I'm trying to highlight through example. I've got a phase dim downlight. I've got a 0 to 10 high voltage on the front. I've got pulse width modulated RGB cove lighting, and I've got a constant current going to the up-down CCT fixture. So what does that look like? Well, essentially to do this, I have to essentially, oops, let me buzz through here. I realized I was clicking the wrong slides. So now I've got a phase dimmer that essentially is going through and attaching a circuit to these 4 downlights. I've got a single controller to this because it's in a daylight zone. I've got a 0 to 10 to these 2 fixtures, and then I've got a different set of controls for the other downlights and for the cove lighting. So limitations of this: daylight requires multiple phase dimmers and multiple circuits on the 0 to 10, which increases the cost, and change orders are highly likely. And then not every fixture is individually controllable. I bring in PoE, and now essentially I use the same hardware and I just program each fixture, because it's individually controllable, differently to respond to different things like the daylight sensor or the occupancy sensor. So with PoE technology, essentially I can move a lot of that differentiation into software and have the same physical piece of hardware control all of this. So strengths are that it's all low voltage, you don't have any conduit requirements. Your changes are very, very flexible. I can change who responds to what whenever I want, and I've got lower CapEx and operation costs. Here's another application example. Is a facility, research facility. Essentially, this is a 2D map, but essentially we've laid out different lighting. Each of these fixtures is individually controllable and color tunable. So with one system, we're essentially able to tie all of these together, wall switches, and everything else. We always get asked about emergency, UL 924, and power cycles. Would love to have a more in-depth conversation, but here's just a quick highlight. We advertise and recommend 2 network stacks, one that's UPS backed, one that is not. And essentially this gives you the flexibility of choosing whatever fixtures you want to be UPS backed. So this is a substantial advantage, for example, over a traditional hardwired conduit system, because we essentially can just swap Cat5 cables from one stack to the next. We can also detect when the utility power is lost and essentially invoke an emergency scene. An emergency scene can set lights to a specific level, but it can also do things like email someone to let them know that the power has been lost. We also have a device that is essentially more of a mechanical equivalent. So if there's any concern that data could turn off the lights, when the power is lost for the same mechanism, essentially it forces the lights into 100% with no data capability, or no data can be passed through, essentially forcing lights into 100% state. And then other recommendations in terms of supporting power cycles. So essentially we recommend having a network switch and a router that assigns static IP addresses to the gateways. Make sure that the software in the system is what I call self-healing, which means that it will go and make sure that all of its communication links and loops, IP addresses is consistent, at least running every 15 minutes, and make sure that the end node, when in the absence of being commissioned or any kind of software, essentially will bring the light to a specific level, be it 30%, 50%, whatever the case may be. So thank you for your time. I appreciate everyone's patience. I'm happy to take questions if folks have them.
Joe, we did have a question. I have been chatting with Peter on the YouTube channel, and he's been looking at DMX lighting. So would you mind taking a minute to discuss what do you think the differences are, pros and cons, for a DMX lighting system versus a PoE-based lighting system?
Great question. My family comes from, and my family and our chief hardware designer all come from deep theater backgrounds. So DMX is near and dear to my heart. DMX is a phenomenal control standard, and there's a lot of really great high-level software written around it. Number one difference between it and PoE is that DMX does not carry power with it, it just carries data. So you still do need a separate power cable going to each fixture. And then the second is that DMX doesn't really do energy code. So you can't really get a DMX system that responds well to an aux sensor and supports California Title 24. So in an executive conference room, where you have to have daylight response or occupancy response, it's really tricky and hard to get a DMX system to respond the way that a normal lighting control system would be. And it's because it was essentially designed to be 100% manually controlled. Probably the third and final is that DMX is a little bit of a black art in that if you just put it into a facility manager's hands, they'll probably freak out. So DMX does require some level of technical sophistication, and in order to widely deploy it in commercial real estate type applications or high-end residential applications, the details of the DMX infrastructure have to be kind of essentially, I don't want to say hidden, but they can't be directly, the facility manager can't be expected to just manually run a DMX-based system. So hopefully that answers your question.
Well, that's a great answer. Thank you, Joe.
Mm-hmm.
Well, I'll just give a quick shout out to the audience there on YouTube. If you've got another question for Joe, put it out there. Otherwise, we're going to let Joe get back to chatting and supporting customers at the Bixie Show. So thank you all for making time. I'm checking the chat. We don't, sorry, brain freeze. I think we've covered most of the questions. So thank you, Peter, for the questions and the discussion on DMX Online. Thank you all for joining. Joe, do you have any final comments before we wrap it up and send everybody home for the day?
No, if you have any questions, feel free to catch me on my email or catch us on the customer hotline at POE Texas.
Okay. So I'm going to fade over here real quick, Joe.
Mm-hmm.
Make sure I can see my face here. All right, I think I can. So thank you all for coming today. I really appreciate all the audience and everyone out there. Let me flip this video over for our Zoom here as well. So thank you all for coming. As Joe pointed out, we've got 2 more sessions coming up here with POE Texas. Tomorrow at 12:15 Central, we are back, and Joe is going to be presenting the top 2 pitfalls for POE designing with lighting, POE lighting. And for those of you who are really interested, tomorrow afternoon at 3:45 p.m. Central, I'll be back here doing a training on how to present and. So join us again next time. Visit us at POETexas.com. Hit us with any questions at success@POETexas.com. Otherwise, I'm going to let you all get to. I'm going to let you guys get back to what you were doing. Thank you very much for joining us. And let me make sure I get to the right spot for a good conclusion so I can end on a bang. Thank you very much. Y'all have a great afternoon.